All right. Where did we leave off? Oh yeah. Man, I honestly don't really know. How do I want to do this? This is my chunk, really. My wall is my chunk. And I guess we should be setting... And the brick exists over here. It's now struck. But then we don't want that. So we don't want to access the voxels like that. The brick is honestly... Hello, Pedakin, how's it going? We don't want this anymore. This. Don't want this. This. Don't want this. I don't know, maybe I should give up on this and just go with like a set voxel or whatever. Check bitwise. So basically, imagine the bricks won't really be accessed that much. Because it's not like we're ever gonna set anything in the bricks. They'll just get accessed kind of by accident when we access the voxels. Hmm. Clear voxel. So what should we take there? If we take a look here real quick. Here's what it ended up looking like, and it was terrible. All of this shit. But I don't think we can get away from this, that's the thing. And this is also weird, because we're not accessing the bricks, so we're just accessing one wall, and then inside that we're just accessing the local voxels straight up. And that's what makes it so weird. I was trying to do it like this so that I would access the walls via indexing, and then the walls would give me the brick, and then I would access the brick via indexing, and then I would access the voxels by indexing. But it didn't want to work. So this is what we've got. This is how you generate a world. But basically what we need to do, I guess, is we need to... Well, setting is easy, because if we just set, I can set everything pretty easily. Because all I need to do is I just need to I just need to calculate which wall we're in, and then I just set it using the position. And it can calculate that itself. But down here then, this is where I'm setting color buffers. And this gets so weird. But when I think about it, they don't really need to be in brick order, in a sense. Well, we don't need to write them in brick order, but I think that would still be preferable. But I don't know if it matters, because as long as we're writing inside of one wall unit, if I write from X to X, even if that passes by 8 bricks for each write, as long as I write the correct brick index for that voxel, that's fine. And whenever we swap out wall data, then we're swapping out the whole thing anyway. So it doesn't need to be in like nested Morton pattern, because that's what's making it hard to really grasp. The annoying part is that the map position is three-dimensional, though it doesn't have to be. But it's easy enough to... It doesn't matter, I think. Because what I'm trying to do, again, is trying to avoid as many calculations as possible on the GPU. So... But since the index on the GPU is traversing 1 in each axis when we move, that map position index is a three-dimensional index. So we still need to convert that index to position every single time. We can't get away from that. So this, the clear voxel, what should that take? That's what's so annoying. Both the clear voxel and get voxel and set voxel. I do want to just feed it current position, kind of, but not really. I don't even feel like it should necessarily be in here. Ugh. We can't get around it. It should be here. Like this. Clear voxel X, Y, Z. And that should give us int wall index equals x divided by 64. Well, vector 3 int wall index equals new wall index, no, equals new vector 3 int x divided by 4, y divided by 64, z divided by 64. I don't know if I need to... because it says that it's an int operator, and we have integers on the right and we have integers on the left. So I don't think I need to floor it. Then we need to access walls, wall index.x, wall index.y, wall index.z. And then we've got a bit mask array. that we can set to this, I think. But it also needs an index. And what is that index? Brick mask index equals... That's this, right? Think so. Then we access brick mask index. That. And X. That. Okay, maybe not. Maybe we keep it here. Oh, I hate this so much. So we've got an index there. That's going to be a this is brick bit index. No. No, this is just the bit index. And then, like, this should be right. But after this is done, we also need to... We need to do the same thing, except here we need to do brick array. But now the brick array is 3-dimensional. Oh, I'm gonna have a stroke. That's gonna be x divided by 8 modulo 8 y divided by 8 modulo 8 z divided by 8 modulo 8. And then we need to do dot bit mask array. We should have that here, right? First, clear voxel. I need some socks on my feet. God damn. We've got index, and we also need an brick bit index and voxel bit index. The voxel bit index, I guess, is just gonna be y modulo 8 plus z modulo 8 update. That's gonna be there then. And like that. Then here we just do voxel array equals new voxel 0. As content bitwise. But now the bitwise, it has to check for brick array. Okay, this needs to be a 4xyz. Brick array dot get length 2. Brick array xyz dot pick bitwise. No, 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 no. We don't need to do that. We should just do we have to access this twice, which sucks. But bit mask array. What we could do is that's still in here, right? What we could do is we could make a bit mask array setter. Really know how I want to do this. Because this is for the... set bit mask array. Okay. And then we say int index. Then we'll say bit mask array index. Come on. Oh, it's so tedious. Oh, I hate this. Whatever. Let's just do this. Let's just do this twice. Even though it's disgusting as all hell. What I was trying to do was I was trying to implement a method that we could just call, and we would just call it once with this, and then when the bit mask array gets set, it does the check bitwise. That's what I was trying to do. But I and equals byte wiggly line 1 point x bit and then check bitwise. Shouldn't be more than that. Then we should be able to do dot set bit mask array. We're using voxel bit index and bit. No. X. There. Now we're only doing one of them, I think. However, well, now this is clearing, and that is clearing, yeah. So we are clearing those bits. Oh. Set the voxel. And this should be clear bit mask array, or clear bit, let's call it that. And then we need set bit. That's gonna do the same, except it's gonna do that, and no squigglies. Not gonna lie, I'm getting a little bit overwhelmed by this and the other project at the same time. Both being in the same hell, just refactoring and messing around with data types. I don't know why, but my brain just can't deal with this. It was a lot easier to try to figure out the path of the ray with all that math we were doing, like pages and pages of math. That was so much easier than this. And this isn't even hard. Like, it's literally just the planning stage, more or less. It still has all of these fucking modulos, though, and it's super annoying. It shouldn't be this hard. All right, let's get back to over here. Huh? Oh. Yeah, why does it want X, Y, and Z? Well, whatever. We're just doing this. Clear voxel. In fact, we'll probably end up changing this to a vector 3 int, or even a vector 3. But we'll see, whatever. I think that's good enough. Oh, god damn. My foot ache. Like, it was really bad, my feet ache. And it's moved to my knees. That's my knees. That shit's terrible. Hello, Max. How's it going? Oh, my knees. Okay, so, whew, now I have to write this fucking... Like, this is killing me. Like, just looking at this is just... Oh boy. I need a coffee, but I can't drink any. Neighbor's dog is barking as well. Of course. Her son is yelling top of his lungs from the other side of the apartment at the dog. This does not help. The dog only starts barking more because he's yelling at the top of his lungs. And this repeats for several hours every single day. And it doesn't matter how much I complain. Maybe putting the focus caps on helps. Oh, didn't. I need to turn the Breath of Fire soundtrack back on again. It's the only thing that's keeping me going. It's the only thing that can stave off death. Or is it? Well, we can do Breath of Fire. We can do a couple of things here. We can do Chrono Trigger maybe. I like that Chrono Trigger has Chrono Cross in it as well. Yeah, sure. Chrono Trigger, Chrono Cross. Deltarune. And I don't even remember. Nah. I didn't add it. And it overwrote everything else. Oh shit. Things are not going my way. Breath of Fire. Chrono Trigger, Chrono Cross. What else do we want in there? Phantasy Star Online 2. No. I want Phantasy Star 4. The Star Ocean, Suikoden side soundtracks didn't really grow on me much. Wild Arms. Xenogears. Oh, it did it again! Oh, that's a bug. Holy shit. It's not right. If I start dragging a folder and I stop dragging it, if it's not above Winamp, it just replaces everything with what I'm holding. What did I put in there? Wild Arms. And Xenogears we already put in there. SNES, we can go with the Light Blade game. Lufia 2. Going with Paranigma. That's about it, I think. Oh boy, there. "32 times 32 pixel art, 100% drawn by me." Let me give you a small piece of advice when it comes to pixel art and picking resolutions. Smaller is harder. But as long as it works out for you. But I'm just saying, if you're trying to draw like characters and stuff at 32 times 32, this is really hard. My first game, I had characters that were like 48 times 48 or something, and that was really hard. Because I wanted like a realistic style, and Jesus Christ, it was so hard. Because when you go big, you need to draw more details, right? And then that becomes hard. But when you go too small, you can't draw anything. Like, you want to fit any kind of detail, you just can't do it. And it just becomes a total nightmare, especially to animate. But it all depends on what you're doing, right? Ooh, okay, so can we figure out how to write out this buffer now? Can I do that? Can I access these voxels at all? If I do here inside this, this needs to give me a voxel, and this is just X, Y, Z. Return voxel array. Yeah, but like I said, even 32 times 32, it's really tiny. But it's better than doing nothing. And again, it depends on what you're doing. Like if you're making a shoot 'em up or something with spaceships and whatever, you know, like Gradius or Tyrion or something, then you don't need sprites that are that big. But like if you're making Doom sprites are a lot bigger than 32 times 32. A lot bigger. You'd probably fit like the head of a character in Doom in 32 times 32. So that's what I mean, like it depends on what you're doing. So it might be perfectly fine, but I mean you'll notice if it's too small or not. So just keep it up. But going too small is one of the most common beginner mistakes in pixel art, for sure. So what we want here now is we want to set our voxel data buffer And we want to set it... It's a long one-dimensional array, and we want to set it per wall, per brick, and then per voxel inside. So we start with the voxels in the first brick in the first wall, and then we go to the next brick in the same wall, and then we do that until we've done all of the bricks, or all the voxels in all the bricks. And that's where we need to figure out what the math is here. So now I've accessed the wall here. And then we can again access the voxel. But what's the voxel going to be? That's what I feel is a little bit... How do we get the math? It's just gonna be y. Y. Well, we have x, y, z here. So it's going to do the x. All we need to do is x, y, z plus bx times 8 plus yx, oh no, by times 8 and zy times 8. No. Bz. Yeah, no, smaller is way harder. I couldn't even make these sprites that small, to be honest. Like 32 times 32 is minimum. And even then, a 32 times 32 sprite is like barely even here. Wonder where I saved those. It was like one of the first things I made for Gibbs. Wonder if I can do this. Screenshot it. It's not perfect quality, but like this is an emote I made for Gibbs way back, and this was 32 times 32, and like you cannot fit a face. If you want to have like a character with a body, you cannot fit a face. It is not possible. Not really. So you have to make like characters with no face if you want them to be like you can have eyes to some degree. Kind of. It's crazy how small it is. So my voxel data, we're setting the color index there. And then the next one is the brick index. And the brick index is... that's going to be kind of the same thing. I wonder if this is actually correct. W plus WX, or WY plus WX times map height plus WZ times map height times view distance, and then all of that times 8. And then we have BY plus BX times 8 plus BZ times 64. I think that's actually correct. I think this is right. And then we write that to the data buffer. Yes. Man, I don't know. What's happening here? The color buffer, voxel data buffer. Why do I have 2? Because I need to write a brick buffer as well. Yeah, I've never done this before either, to this degree. Now this shouldn't go by anything like this. This should go by... I was very bad in English at school. It's not your fault. It's the German culture. Basically, I'm 34 now. And from what I've noticed, basically every single country in Europe that didn't translate their movies, like just had movies in English in the cinema and on TV, etc., etc. They've all gotten better at English. They're all pretty decent now, even Finland. But Germany, Spain, France. No, but nobody there knows English. Spain is probably better than both Germany and France now at English. What if I do this? Ah, Ah, whatever. We're missing some things now. I don't like having my buffers all the way up here. Let's move them down. Voxel data buffer, brick data buffer. And then here we need a voxel data buffer, and we need a brick data buffer. This has brick data. Voxel data, this is not a thing. What's going on here? Yeah, I'm trying to write. Yeah, that's what I mean. Because Germany is still translating all the movies and all the games. More importantly than everything else now, that the games are translated to German. If the games were still in English, you would see so many people who are so much better at English at this point, but Germans just don't have to learn. Because almost everything is in German. How are we doing this? This via set voxel now? And then I think that should work. Poor Germans. Not setting the bitmask array here, there. Voxel data.length. Okay, so our brick buffer is going to be walls dot. No, it doesn't need to be wall socket length. This is going to be int world size equals view distance times map. And then this is going to be world size times 8. And then voxel data buffer, voxel data buffer, voxel data buffer, voxel data, brick data. Okay, so this is our brick data. Brick data buffer. Brick data buffer. Brick data buffer. Temp voxel data buffer. Temp brick data buffer. What it was is supposed to be called, right? These are the arrays. This is gonna be called brick data n array and voxel data n array. Temp voxel buffer. We're also going to have a here. We have brick data, we have voxel data, but we also need wall data. Eve. And here we have a wall. No. The wall data, it just has a color index. Because the idea is that we go into our voxel, and then we can read the color from the voxel, or we can read the brick index. So then we take the when we enter a new brick, we check the voxel, and then we take the brick index, and then we check the brick, and then the brick inside it also has a color, and it also has a wall index. So then if its color is also 0, which means it's empty, then we take the voxel or the wall index, and then we check the wall, and if the wall has a color, then we know that we need to ray trace into the into the wall at the brick level. Absolute insanity. Wall data? Wall data and array? Oh, why am I making such complicated games? I could be making easy games. I could just be making like a 2D little Harvest Moon clone. I'd be basically done at this point if I had started doing something like that. But no, you have to start a mega project. You have to do raycasting, GPU accelerated raycasting rendering. Here's what I want to try doing later, because what you can do is, if I can get the terrain ray tracing to work well, then I want to try doing what they do in Teardown. And basically ray trace into individual voxel spaces. Because then we have like the world voxel space, but then we also have object voxel space that needs to be ray traced. And with that, I want to try making a pixel art kind of filter. Because what I want to do is I want to try just, we render whatever is on the front of the character, and then we take those voxels, and instead of giving them shadows and like 3D, you know, I want to turn all of the faces towards the player or towards the screen. So that instead of having a block, we just turn all the pixels towards the screen. And see what we can do with that. But I'm not super confident about it, because I've seen so many pixel art shaders in my days, and they all look like shit. Like they never ever work out. Not once. Especially because when you're... The whole key of animating when you're animating with pixel art is to keep it smooth. You don't want like pixels jumping around all over the place, and you don't want like small little pixels popping out all over the place. And when you're doing that by hand, it's pretty easy to keep at bay. But once you take a 3D model and you convert it to voxels, or even if you don't do this, you just take a 3D model, and you take the resolution and you just lower it, and you kind of give it like an outline or something, you can't control it anymore because you have so many angles, and there might be like a little detail on your sprite or on your model that creates like a little spike or something out in the pixel art outline, and especially when it animates and it like moves an arm or something, if that's just animated using inverse kinematics, you know, it'll just move smoothly and it'll not look like pixel art, and the animations won't look like pixel art animations either. So you have to basically you can just reduce the frame rate on the inverse kinematics, but that doesn't work. That actually does not work, because then you just get the same feeling as you do when you're watching 3D anime, like you're watching 3D Berserk or like Knights of Sidonia or whatever, and it just feels like low frame rate. Like there's a very big difference between keyframing and just having a low frame rate, right? So if you want to do that, you basically have to keyframe all animations and only play keyframes. No tweening. I think that's how if you want to have pixel art shader or something like that, and you want to animate and you want to keep it having a pixel art feel, you have to go that extra mile. Otherwise, it just looks like crap. Jittery pixels or just choppy, low frame rate animations. More or less. I think whenever I say things like this, it's like a general rule of thumb, because I think you can do anything. I think you can go with pretty much any art style, any direction, any technique that you want, and as long as you polish it and you do it in a good way, you can make it look good. But it's usually a very fine line where something looks good or not. And finding that, it takes some time. That's why I think it's very important as an artist to strongly emphasize iteration, redoing everything. Like, when you start, don't do everything so hard. Like, don't make every single animation for your main ship or your main character and make all of their attack animations. Like, maybe you can do that for one character, so that you have some frame of reference. But after that, don't start like hardcore making every single animation for every single enemy, every single character, every single... And that's for two reasons. It's just, first of all, whenever you start something and you come back, you'll eventually start seeing the flaws in it, and then you want to change it. And if you've made too much already, then you're just reworking everything. And as well as just being an artist in general, you get better. And especially in the beginning, as an artist, you suck ass. So even through the same project, you're going to get so much better that whatever you made in the beginning, it's not gonna be viable. Like, it literally will not fit in the game, most likely, if you have any aptitude at all or try at all to get better. Because some people don't. Like, they literally just make the same things forever, and they don't actually put in any like conscious effort to get better. I mean, that's all up to you. I have several tens of thousands of images saved, pixel art, non-pixel art, for everything. And like, that's how I became an artist. I just always looked for things to copy, and I always looked at other people's stuff and how to get better. And I've not once thought I could never do this. Like, I look at someone who's been a pixel artist for like 20 years longer than I have, and he's like insane, and I'm like, I can never do this. I never think like that. But I know that it's gonna suck balls before I can do that. And learning is not fun. And when I started doing stuff, it took me like 2 days to make like 2 frames from a walking cycle, and that walking cycle would be like 8 or 10 frames. It took forever. I worked on the same character and portrait and like their animations over and over and over again for probably like a year. But I was really, I went really hard on getting that working, and I just kept like going over them forever. It was not really great, to be honest. It's good to polish and put in work on whatever you're doing, but it's not good to get stuck for too long on the same thing, because you stop being able to see. You can't see anymore. You can't tell what's good and what's bad. And the second you get that feeling, you start feeling, is this good or is this bad? I don't know. Then you should just turn off the program and go take a nap. Because that means that your brain just can't, it's too tired, it can't tell anymore what's going on, really. Because your brain gets tired when you're drawing on the same thing forever. So we've got brick data. We're writing brick data array, brick data buffer, brick data, brick data, brick data. Voxel data. Voxel data array. Voxel data buffer, voxel data buffer. But here, this should not... This is bricks. We're writing bricks here, so this should not have these bits. Pick up. Ooh. And then we do brick data array index equals new brick data walls But now, here's the thing again. We have to have a method that says get a wall. Because here I can do this, right? I can get voxels here, but we can only have one accessor like this. Why does it say this? Can I do like that? Whatever. Just do public brick get brick int x int y int z. Then we do that, except this needs to be divided by 8. Well, how am I accessing it? Now the tricky part is deciding on the LOD color. Is gonna be kind of weird. Because the LOD on the bricks and the walls, that's basically just gonna be it's supposed to be if it's unloaded, but I don't see how it can ever really be unloaded. But I guess at some point it might be capable of being unloaded, depending on how we set up the multi-threading and everything. But otherwise it's only supposed to have a color, and that color is supposed to be what is drawn if we are outside of the draw distance. So if we're looking at something really, really far away, that's what that's gonna be. But the thing is, it's hard to determine what to choose to be the LOD color, because let's say you have a mountain far away, and when you look at the mountain is green because it's full of grass. But depending on the method you're using to determine your LOD color, you could just check what is the average block in this section. And if you do that, that's probably going to be dirt. So then you get a brown, gigantic block in the distance when you're really far away, because that's the LOD color for that area. And then when you move closer, now it's green, and that is really weird. It should be like as minimum as possible that you see something change at all, really. That's the whole point of the LOD system, but it's also really heavy to figure anything out. Like if you want to know what the average block is, you have to go through every single block and you have to save them in a little list. And you have to count how many of each you have and then determine, like, this is what we got. And yeah. And if you want to know like what it might be visually, then you have to determine lots of things, like which side is visible. Maybe this side is not visible. But how do you know that? You're gonna have to check the neighboring wall as well and see. Okay, these voxels are all adjacent, so none of these are visible. So you're gonna have to determine that as well. And after you know that, then you can determine what is like the most likely view angle for this. And if that's gonna be like, if all the voxels are mainly visible from up top, then you pick the up top color, or for whatever it is. And to get the up top color, you then have to, you either have to raycast or you have to have like a height map that tells you where all like the highest of every block is, and then you go and then you count what you count everything you have there, and then you take the average of the top blocks, and then you set that. All right. So it's a mess. That's what it is. And that's here now, has content. I think is kind of obsolete. We can remove that instead. And here, once we clear the last bit and we check bitwise, then it'll here it'll return true, but it'll also do color brick color equals 0. And here in the wall we should do the same. Then here we do wall color equals 0. Check bitwise. Has content. Doesn't need that. Has content equals true. See, here the issue is setting the color. And that's just gonna have to be wall color equals voxel of color index for now. It's a uint. Fine. But that also means that whenever we set voxel, we also have to set brick array. Well, I wonder if there's something I can use, some kind of collection, like a dictionary or something. That'll let me tally. Like how many 8s and 0s and 1s we have. Because what I can do is, for example, I can keep a list around that's like, I don't know if it can be static, but so that we have access to it globally, at least. And just have it be the length of the amount of blocks we have. And then whenever we need to check a brick, we can call it, though this doesn't work, but we could call it, and then we could use it to just add whatever index we have to that index in the list. So if we have like color 8, then we add 1 to 8 in that list. And then we just need to find whichever index has the highest number. But that also means that I have to go through, I have to for loop through all the voxel types in the entire game. And it also means that if I'm using this one array or this one list, and just like calling that, we won't be able to do that multi-threaded. So that doesn't work. Oh, I'm losing it. I'm dying. All right. I'm gonna take a little break. I'm not gonna go outside because that's too much work at 9:30. But I do need a little break. Otherwise, we're never gonna figure this out. I don't even know where I am anymore in the code. Okay. I had to take a cold shower. I'm not sure it helped. But I think we're pretty close. What do I even have undone here? Yeah, the problem is that we have to decide which LOD color we're gonna give this. And that's just gonna have to be whatever we put in last. More or less. And we've got the brick array there. That also needs to have its brick color equals voxel.color index. It doesn't make sense to do this, but that's what we're gonna have to do for now. So we're just setting the LOD color to be whatever we put in last into the wall and into the brick. Like I said, that won't fly. But it's a low priority thing, so there are a lot of things that should function on a low priority thread, and this is one of them. Basically, if I update a wall, that wall should get queued, and while it's when it gets unqueued by the low priority thread, that thread should just count through the whole voxel and just check. It should start with the bricks, and it should check each brick and see what do we have in here, and then it's gonna just set that to be the average, and it's just gonna do that, and then it's gonna do the same thing with the wall, but the wall is just gonna be checked against the bricks just to speed it up a little bit, and then that color is going to be determined there. But right now we don't even have an LOD color, but I have to set a color because I just removed the boolean that says that it's visible or not. So now it's just that if it has a color at all, then it's visible. If it doesn't, then it's invisible. It's that simple. And I think generally you want to check the highest tile. So what you can do is you can just check from the top down and then grab whatever is the first thing you find. And if that's like a full tile, then it'll just grab its LOD instantly. More or less. Back here. Get brick.brick color. And then what we want to get then is we want my brick color and we want my brick index. And the index is just this. The brick index is just the wall. And that's the brick buffer, I think. I don't hear anything, so switch that over to speakers. That's the wall buffer. Oh, there. Those should be the buffers we need. Shouldn't have the other buffers in the first place. The same thing with these. Well, voxel color, that should be called voxel color and array. Did not exist. And we've got that, and there we've got CS color buffer. Those should exist. So close now. Attempting to create a zero-length compute buffer. Voxel type arrays, that's not the problem. We need a map height. The map height is going to be 4. And the view distance is going to be 4 for now, I guess. Index 64 is out of range. Yeah, fair enough. This one's gonna be wrong too then. Because what we're doing is we're writing... Down here, we're writing the voxel index. So this needs to be times 8, or times nothing, and that needs to be times 8 there. And here, get brick. It's probably also gonna be like that. Index 5112 is out of range on the brick data. It's the native array that's doing it. The native array world size times 8. This is a brick data array. But that works. So why does this work then? World size times 8. This should be right, shouldn't it? The index that I'm accessing is this then. Times 8 there. And here it's just times nothing. Can we oh. Is this not enough? It should be. World size times 8. Yeah, no, that's enough. Because, well, what did I put this on? I put it on 4 times 4. That's 64. Times 8. It's 512. what? Breaks. That's not right. No, it should be it should be 4 times 8. That's 32. So it should be 32 times 32 times 32. That's the number we want. But I was trying to do 4 times 4 times 4 times 8. And that's not at all what we want. That's not what we want either. But we can do 512 there. But that also means that this is times 512 times 512? We're still at the brick. That's still not right. Man, I don't know how to get this value. I'm just gonna do this then. Can you do you have I don't have to do parentheses here. We can just do 4 times 8 times 4 times 8 times 4 times 8. No? 4 times 8, 32. Wait, what the fuck value am I trying to get here? Now it's 4 times 8. So it's 32 times 32 times 32. 32,000. That's what we're trying to get. So 64 times 512. That's correct. Fuck off. It doesn't even get to the index now. Why can this not be larger than 512? It's because I set it incorrectly up here. Here is where it's wrong. How about now? Yep, now it's getting past it. Now we're getting to the shader. Property bit masks at kernel, blah 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 blah. Yep. House array tracer. Let's cry. Now we are going into the shader finally, but going to suck balls. If check house bit mask, new house. That's not what we're doing anymore. We need a new function. And what should we call it? Int check house content. Int house. And then we're gonna do, let's see, structured buffer, voxel data buffer, structured buffer, brick data buffer, structured buffer, wall data, and then we have voxel data and we have brick data, and this is going to be a uint This is also a uint. Color index. Now a float for color. And we've got wall data, which is simply color index. We got bit masks, voxels, those. So house index, then we're gonna do return house buffer house index dot color index. It's not called wall, house is called wall data buffer. A color index, and that's it. That's the whole function, right? Check brick content, brick index, brick data buffer, and we'll do int check a voxel content. Now this one might be a little bit different because this is just going to parse in the map. So this might be float int3 map position, and this is where we will actually have to do some shit. Voxel data buffer int index equals 0, index not color, like so. This is actually a uint. And then here we have to get brick. And it's based on map position, right? So we have to write get brick get house. And they're gonna be to get the brick. I want to first rename this to map position. In fact, I kind of want to name it voxel position. I don't really like the map position term. And then here we have brick position already. So to get the brick, that Well, no, we need to get the voxel. That's what we need. We need to get the voxel. First and foremost, we need to get the voxel. And this is going to be brick. That's still going to be voxel position. So now, how to get the voxel, that all depends on how you structured it, structured the array in the first place, right? And this is what I wanted to avoid in the first place, but I don't think we can avoid this first one. Purely because that's just how it is. But I think it's gonna be awful. But not necessarily. Because we also have this, right? We have int3 brick position, and we have int3 wall position. We have all of these things. To help us recreate the voxel index without doing a gazillion multiplications and shit. So what we need is voxel data buffer, and then we need, this is where we need the index. Int index equals wall position int map height int view distance. So this is going to be wall position dot y plus wall position dot x times map height and see, here's where I guess we'll find out if there's a better way to structure it, to let us do less math here to check the voxel. Because ideally, I would just want to not do this. But I don't think we need these. They don't really help, I think. But I guess they kind of do. You can do this plus wall position.z times map height times view distance. And then we do the big multiplication on the whole thing and do like, what's that gonna be? I don't know. Because we're getting a voxel now, so this is gonna be 512 times 512, right? And then on top of that, we need the brick position. And that's going to be brick position dot y plus brick position dot x times 8 plus brick position dot z times 64 and then another parentheses times 8 think. I'm a little bit confused. Why do I need to do this all of a sudden? Shouldn't this be 64? And however, this needs to be modulo 8. All of them. And then this is going to be plus voxel position dot x modulo 8 no dot y modulo 8 plus voxel position dot x modulo 8 8 plus voxel position dot z modulo 8 times 64, and that's it. So this is our index, and this is the calculation we have to do every single time we check for a voxel, which is very sad, and I want to shoot myself. But now we don't want to return that. We want to return voxel data here. Struct voxel data. Because if we don't return voxel data, then we might have to grab this multiple times, and that would suck balls. And here we unfortunately need to do the exact same thing again. Except, of course, without the voxel position, without the 8 there, and then here we do multiple by 8. And here we just need that. Well, I don't know. Maybe I'm making a huge mistake writing it like this. But I don't know if you can avoid this. Because even if I write I don't think you can get away from this. Because regardless... I could maybe just write the voxels just in a row. From X, like just X, 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 X forever. But... I feel like that's gonna make it so hard to chop it up and like replace things later in the buffer. Because this way, if I want to replace an entire row of chunks at the bottom or at the top, I can just take that many, like, because they're all of those chunks are in a row. Because it's X and then it's Y. No, it's Y and then it's X. And then Y, X, Y, X, Y, X. So for moving it this way, all I have to do is chop off an entire section at the end or the beginning. And to the sides, it gets a little trickier, because then I have to chop off, you know, sections and replace those. But if I don't structure it like this, I think I'll still have this problem. And it'll be harder to move the data. It's just that when we're traversing a brick, we end up having to do this every single brick step, and it just sucks, right? Like that's just the fact. And here, like, get voxel, ray position, brick. This was kind of how I was doing it before. How did this grow to that? I think I could just do this. But I would still have to get the brick. And no, this doesn't work. This was all designed based on when... well, it might work. But we should be able to get wall, brick, and voxel data there. And once we have the voxel data, we can get the brick data easily, right? I don't think it helps. Like, does it help? Does any of this help compared to how I was doing it before? I'm not so sure. Because what's gonna happen is that I'm gonna move into... We're traversing the voxels, right? And then I traverse into a new voxel, and then I check. Like, we have to get that voxel data. Like, we have to get that, no matter what. That's the first thing we have to do. So we get that, and then we tell that, okay, this brick index is different from our previous brick index. Okay, sure. Then we can make a brick check. And we can just check the brick, like that's where it speeds up, I think. But the voxel data, it looks worse than before. And I don't really know how that happened. But we get the voxel data, and from the voxel data we get the brick index, and we check, is the brick index a new index? If it is, then we go and we check the brick simply by just plugging that in. Because there we don't have to do any math, we can just go and check brick 2 if we were at brick on brick 3. So we go check brick 2. Brick 2 has content, yes, no. No. If it has no, then we can instantly step up to checking the wall again, because now we have the brick. And then we have the bricks. Wall index. So then we can check the wall, and then the wall is gonna say, yeah, there's nothing in here either. And then we know that, okay, now we can skip walls. So then we just skip walls until we find a wall, or we find something that, or a wall that has something, or we exit the map. And yeah, but otherwise we just traverse the world on the brick level, which uses that math. It's still shit, but I don't know how heavy modulo is compared to like division. I don't know anything about modulo. Let's see. Programming division versus modulo. Performance. Modulo is even slower than division. Yeah, whatever. So now, here, we have a map position, right? So we get brick. This is no longer a uint. This is going to be brick data. So we're gonna get brick from... no, let's voxel data voxel equals get voxel map position, right? Okay, that needs all three, I guess. And house map position. There, now we have a voxel. I don't really like that we had to do that, but I don't know how to calculate it from only the voxel. Or maybe I do. But it's gonna be divisions and shit there too, so I don't know. But now that we have the voxel here, we can just say the brick is going to be brick data buffer voxel.brick_index. That's all we need to do. And our wall data house is now a wall. That's gonna be wall data brick.brick_index. No, brick dot house index. That's not right. Wall index. Yeah, that one's wrong. I'll be right back. And here now I feel like we want all the voxel. And we want brick data. New brick equals brick. Well, yeah, let's go with old brick rather than. I didn't like that new vernacular I was using. And here all we need to check now is if wall dot color index equals 0, and here else if brick dot color index equals 0, then we do that. I wish Xenogears and Xenosaga weren't shit. They were kind of cool. For a while. Well, Xenosaga was kind of not cool, to be honest. But I did like Xenogears' general themes, even though the gameplay was silly. Like, again, it was just Final Fantasy 1, so, I mean... If a game can't be more than Final Fantasy 1, then I just don't really care. And it's just Final Fantasy 1. Mechanically, it is not really different. In fact, it might be more shallow than Final Fantasy 1, but I'm not sure. I do not think that we are going to manage to get anywhere here. Check house bit mask. This should not be there. This is just for testing. Is array in world. I think we can still use this in the same fashion. So is ray in world is no longer like this. This is now view distance, app height. Why is it times 8 though? What was it before? Brick grid size times 8. times 64. Right? Because every view distance, map height, view distance. Well, yeah, no, it should be like that. And then the ray position, that's what we feed in here. And here I'm just setting map position. Brick map position, we multiply it up, and house map position, we multiply it up by 64. So yeah, that should be right. And then here now, I'm gonna do that, and we're new brick, check voxel. Well, yeah, this is for traversal level 1. Yeah. I could probably traverse it here as well, because I think this step is kind of wasteful, but brick map position, wall map position, wall house map position. Check voxel. It's called old voxel equals voxel. Voxel equals get voxel. Like that. And then here we do check voxel. This is for checking if it has anything in it, but we don't need to do that. We just need to do voxel dot color index does not equal 0. Then we just go in and we're done. Well, okay, not quite. We go in here, and then we need to get a voxel here. Oh, I really don't like this. Because we have to do... this stuff here. And this... Well, this was an issue before too. This can potentially... extra rates that may potentially flip house slash or wall slash brick position. And if it does, then we won't end up doing that. Now, there should be an index value that we can make that can tell us, like if I am on voxel 736 and I want to check the voxel that's to the right in the world space in a 3D sense, there should be a number that we can use as plus minus instead of rechecking the whole thing. The question is what that number is. I think it's based on... It's probably based on... Well, it's not necessarily the case. Because it depends on if I move inside the same brick or if we end up moving to the next brick. Because then that's gonna be completely different. Whatever. You know what? Let's chill out on this. Let's just take all of this there. And now we only have a break. Because it works. It works without all that, but we get some minor artifacting. And now we want to say old brick equals brick, and then we want to say new brick equals, or we want to say brick equals underscore brick data buffer voxel dot brick index. And then we check if brick dot... Now if... We don't even need to do that. What we want to do here is we want to check if voxel dot brick index does not equal old voxel dot brick index. Then we iterate the brick as well. And then we iterate that, and then we say new brick. And then we say brick equals underscore brick data buffer index voxel dot brick index. And that's it. Old brick equals brick. Oh, this is a problem. How do I check the old? Well, okay, we basically have to do that. We have to keep the brick. Until we do this, we need to check if brick dot wall index does not equal old brick dot wall index. Then we iterate the house, and then we say house equals wall equals wall data buffer brick dot wall index That's it. And then we set old wall equals wall. Is there even ever any reason to check the old wall against the new wall? Not really. I don't think there's any purpose to have an old house. I kind of do it here. Yeah, no, there is. Yeah, no, there is. I'm stupid. And then here we're gonna say if wall dot color index is not equal 0, then we traversal level there. Else traversal level 2. And then here we're checking if the wall index is new. And if this is still the same, then it's gonna say else if brick dot wall dot color index does not equal 0, and traversal level 0. And then here we say old brick equals brick. And then here we say old voxel equals voxel, I guess. And then here we are traversing the brick specifically, and this means that we no longer have a brick here, or we no longer have a voxel. So here we have to say brick equals get brick position this is still called house map position. And then we set old brick equals brick. And then here we check old house equals house, so it's called old wall equals wall. Now, when do I do it here? Voxel.brick index does not equal, we just check if brick.wall index does not equal old brick.wall index, and old brick needs to be set here after everything. Then we increment the house. Then we say wall equals get wall house map position. Wall equals brick data buffer equals wall data buffer brick dot wall index then wall equals wall. Then we're gonna do if wall dot color index is not equal 0, if brick dot color index is not equal 0, then here we have to change the traversal level and we have to reconstruct our map position. And that's gonna say... Now if this happens, we have to do map position equals ray step, and then we have to do voxel equals get voxel map position brick map position wall map house map position, and then old voxel equals voxel else if brick dot color index not equal 0. What did it say? Yeah. Then we do that, and we do that here. Else, and now we're traversing houses. As we're traversing houses, we're gonna do wall equals get wall, and that's just gonna be house mass map position, and then we're gonna say old wall equals wall if wall dot color index does not equal 0, reversal level equals 1, and this is where this is so ugly, all of it. New brick equals get brick map position. I kind of think it's probably faster to recreate the ray here, because if I get the ray, then we have the brick mask as well. So it might be better, but brick equals get brick map position. Isn't that right? No, it also needs house map position. Then old brick equals brick. Check if brick dot all dot color index does not equal 0. Then it's all fucked. And we go here, we do voxel equals get voxel position, brick position, and house map position. Old voxel equals voxel. Then here, here in the color buffer, all we need to do there is code for color equals color buffer voxel dot color index. That's it. Not convinced this works right now, but can run it and see what happens. Cannot convert from const struct voxel color to float form. Dot color. The odds of this running tonight is about 1 in 4 billion. Yeah. As I thought. However, it is technically running. It's just not reading anything. Can we skip that? Can we skip Rain World? Well, we can do it, but what if we just not break? Then it's all just black. What I want to try is... what if in the beginning here we say result id.xy equals color buffer 0.color. We say 1 return. Now, are we reading the colors in the first place? We are. So the color buffer works. And what? So what might be causing it to not render? I mean, I think it should render now. What we can do is we can try doing something like this. Int I test equals 0. And then here we set int I equals, no, you set this, that. Then while I test is less than step limit, I test plus plus. Set step limit to 255. And down here, when we draw a sky, let's set this to be this divided by 255 times I test. That's the sky color. And then we get rid of that. Oh, Robert. See, now it's black again. That's because I did this. Because it thinks that it's outside, like right away. Oh yeah, we're not actually setting. It's, I think, on start we set brick grid size there, but we're not setting cs.set int. Distance, cs.set int map height. Is that it? haha, we're drawing some bullshit. But it's not great at all, whatsoever. But we are drawing. That is a huge step forward. But now we have to figure out which part of the formula doesn't work, etc, etc. But I think what I'm gonna do is we're gonna do this. It's really tedious though. Disable it. Let's do if traversal level greater than 0, then traversal level equals. Is that enough? I think that's actually enough, perhaps. Alright. So now we are at least traversing voxels exclusively, and that's where we'll start. We'll figure out the voxels, and then we figure out rest. Because it's actually really easy. It's literally not doing anything other than just traversing the voxels and just checking them. So with that said, it's really strange the way it's behaving. Which probably means that this is not right. It's typically what it means. But this is also not right, there's no way. Now we get nothing instead, that's cool. Well, let's put it this way. This is 64 right now. If we have moved from wall position Y up, is this? Feel like this doesn't work, does it? Let's say we have 1 plus 1 times 4 plus 1 times 4 times 4. That's 16, 21. And then we multiply that by 64. Yeah, that's nowhere near right. What if it was 64 plus 64 times 4 plus 1 plus 64 times 4 times 4. And you get the same. What the fuck do I have here? What is this value? But this is 512 times 512, and this is times 512. I think. Well, it's not drawing any colors, but we are seeing the walls. Oh, yeah. But I am updating those, so that should still be fine. I am keep the map positions are keeping track. What's going on? So now I'm pretty confused as to why it doesn't draw anything at the moment. Because like this is the wall. What if we do this thing again? Divided by 255 times I s. Yeah, so now the brighter it is, the further the ray has traveled. We can see where the walls are now. For some reason it won't draw their colors. Let's not bother with those until we get the voxels working. It's still not drawing anything. Like, not even one voxel. That's what's so strange. Shouldn't it draw one at least somewhere? Oh, hello. What is going on? What is going on? Am I inside long tubes? So, the voxels are here. They are not structured the way they're supposed to be. And neither am I finding them correctly. Like, this just appears, and then this becomes... this? How is this even possible? Anyway, that's gonna be it for today. My Morton Morton conversions are obviously broken. I don't even know if Morton is the right word. That's the only word I know. But it has something to do with this. Or specifically, it's the index here that's weird. But basically, one Y in brick needs to be 512, and one Y in wall needs to be I don't know if this is a big enough number, but it seems to be based on that. Otherwise, this would have complained. So this should be right. Wait, did I put these in the wrong order here? Not so sure I did. No, I did. That's a shame. Y, X, Z. So we're getting the normal voxel position, and then we're getting the intra-wall brick position, and we multiply that by 512 because every brick step is 512. And then the wall position, it's multiplied up by the map height and the view distance. And then it's multiplied by 512 times 512. That's 262,000. And one brick is 8 voxels, and one wall is 64 voxels. 64 times 64 times 64 is 262,000. So yeah, this is the correct value that we want. The question is why it doesn't want to give us what we need. It might be the rays, but not quite matching up with the X and Y that I switched around, but I don't think so. The Z is the distance. Like that's just how it is. Y is up and down. The only thing that matters is how we try to grab our voxels now. But it makes no sense the way the way it happens there. Where we just kind of walk into some fucking invisible segment like this. This should be impossible. That should be visible. That makes no sense. Because how can I be traversing with my ray there and I don't find anything, but then when I walk there I can find it? That means that the rays are like traveling all over the place. And that means that that means that this is still broken. Here really. This didn't make any difference. And neither did that. Right, same way still. Well, we cannot solve that, so let's stop streaming. Tomorrow, probably no stream until the evening. We'll see. Anyway, that's that for today. Until next time, thanks for hanging. Have a good night. Bye-bye.